Thank you very much, Mr. Chairman. Ladies and gentlemen, I would like to introduce you to a new world of design. And I would like to illustrate that with a team that we would like to design for and with communities. And I want to show you some results of our student works, of the undergraduate students and the third bachelor. And I will first give some theory around this that is also taught to the students, and then they have to do a case study to apply that, and I will illustrate that with one of the case studies. My main field of research is really not purely in education, but it's rather in industrial design engineering. And there is one very important aspect to the way we are looking at design. It's really that we look at as a mean to do transdisciplinary research, so research that we obtain with other research groups within our university. We have around 11 faculties. We have around more than 100 research groups, and we are collaborating over different faculties. I'm also teaching right now a university-wide course on co-creation where students from all faculties could participate. I will give a lecture on that later on. I was very pleased to be invited as a keynote speaker. It's my first time at this conference, but I think nevertheless I would like to take you with in my route to that. I also would like to mention that I'm an academic director of our Bachelor of Science, Master of Science, and PhD program on industrial design engineering, and so I'm also responsible for all quality measures and quality control of this education program. My content of my speech will go about 4 topics. The first one is that we are at a new era of design, and we are also at a new era of our society. And this needs new insights, and that's what a lot of students are confronted with. And then I will go in more detail on how we do this, what is the methodology behind that. It's about open-endedness, it's about change, because this is a conference on systemics, cybernetics, and informatics. You will see that we are trying to associate design with those topics. And then I will illustrate that by the case study, designing for and with communities. Well, the new era of design really starts with the definition that was given by Horst Rittel. He defines a wicked problem as a problem if you want to solve it, and that the moment you create a solution, the understanding of the problem immediately changes. That's in fact what we are coping with in today's society. If you're looking, every attempt that is taken in whatever situation, this is really something that is a challenge. And this requires new teaching methods, this requires new research methods, and so on. Especially, how do you solve such a wicked problem? Well, by iterating. While normally in a regular development process and a regular research project, you start by gathering data, you analyze them, you formulate solutions, and you implement them. In a wicked problem, you have to iterate very fast. And you will see that everybody is following other solutions and come up with other types of solutions, and it's the integration of these solutions that is important. And what you typically see is that you are more quickly going from defining not a perfect problem definition, but from a partial problem definition to a partial solution, back and forth. On what type of problems do we apply these kind of wicked problems? Well, it was already mentioned, the Sustainable Development Goals of United Nations is one of the illustrations that we are applying it to. But we'd rather also go a little further, and I'm citing John Ehrenfeld of MIT, which is the founder of the Flourishing Movement. We should strive to sustain the possibility that human and other life will flourish on this planet forever. And this means not improving things step by step, incremental, but it's really a radical change in the way we have to look at life, at human life, at other life, and respect that in all means. And we also believe that education is an important thing. Our university believes in that. This is the main building of our university. And the slogan that is there, the next big thing will be a lot of small things. We believe that we can change the global goals by acting very locally and respecting the local culture of living together. And so we would like to create a flourishing world by involving, inspiring, and empowering local communities. And we are doing this really literally. We go into the city. We try to go to different types of communities. I would also like to situate that transdisciplinarity is really the key to that. And I would like to situate Mrs. Oxman, who made a kind of model where she says, okay, we do the creative cycle, or the cycle of creativity is really on two domains. It's really differing between what we call the human side, so the cultural, and the natural side, which of course now we try to associate with technology, but we should return back to nature there. And then of course we would like to look at, let's say, the more perceptive view of it and a more productive view of it. And if you look at the scheme, you find a lot of sciences on there. And typically, you see that science is perceptics and focusing on nature, while art is also about perception and focusing on culture. If you look at engineering, so science is also transforming information into knowledge. And what does engineering do? It transforms knowledge into utilities. And what does design do? It transforms utilities in behavior of people. And then, of course, artists, they look at this behavior and they want to express what is going well and what is going wrong. And it's really this transdisciplinarity that is important. So we are in a new era of design. We don't design any more products, but we are designing platforms in which people can move forward. And what's important there is that we should not believe that we can solve the whole thing in one system or another. We should be humble about the solutions that we are creating. And we should believe that it comes not from one person, not from one scientist or the other, but it comes from really from the society itself, from the communities and how they accept all these things. That's, let's say, the introduction. That's where we are focusing on. And now let me explain you some principles that we are using and teaching to our students to tackle that. The first one is the open-endedness of design. Well, design is really, as I already told you, an iterative process where we have two types of data. The first one are the real data that we call virtual data or digital data, parameters, quantitative measures that we would like to do. And this is the abstract world which is stable, which is under control, and which designers believe, at least in the past, to be the truth. On the other hand, if you let the designs, if you materialize these designs and you put them in the real world, in the analog physical world, you will see that there exists real use. And this is very concrete. This is really instantaneous. It's dynamic. It's changing all the time, and it's out of control. And by observing that, designers try to change reality intentionally by, again, modifying their model. That's, in fact, how design works. Design is really on the theoretical side, but we believe that we should not only focus on design, we should also focus on the real side where we observe the things. And that means that we have to go to iterative process of designing, which is abstract, making or using it, and that you typically see that there is some interaction between those. You cannot design any more products or artifacts. Today, we are designing products in order to realize activities or interactions. Interaction design is known very well. Activity-based design is also known very well. But we should not forget that these activities are always performed in a certain environment or context. And we could call that, let's say, a real living environment that we would like to flourish. And we want to flourish it through the activities that we are doing. And let's say the products are a kind of tools that help us to realize that. And that's really the system thinking and system design that we are teaching to our students so that they interact the product with their ecology. And typically, if we leave that product in real space, what you typically will see is that products will change immediately after you have designed them and realized them by interacting with the ecology. For instance, corrosion could occur to metals, and you see things rusting. And it immediately changes really the product in itself. I will give you an example that is quite fun. This was a designer that really wanted to make a message. I'm too cool to do drugs. And he made a pencil to do that because that's an ecological way to do. Well, what happens in time? The message is reversed. It's cool to do drugs. You are even ordered to do drugs, or the pencil itself becomes drugs. So you typically see that the intended use of a designer and the theoretical model and the real use is differing so much. We call that, of course, not everybody will use this pencil in the same way or whatever. We call that ultimate particulars. In fact, our design is abstract and universal, and we believe in the truth. It's simple, it's really rigorous, it uses models, then it becomes general particular, fully particular, and ultimate particular. I will give you some examples of ultimate particulars. That's really some examples out of real life. Like, for instance, the keyboard you see there. Yeah, it's worn out, and typically you could analyze by seeing the keyboard what kind of keys you were using or where you were placing your hands or whatever. Even the window, there are no longer anymore the closing doors, but you can still see what they do, and it's a coincidence that is quite aesthetic. You see the coffee mocha, where typically Italians, if they buy them, they never want to use them really fresh and new, but they only want to use them after they have made sometime coffee, because the taste of coffee should really be in this mocha cup. The statue you see there, it's typically a statue that you see some statues that people believe it brings them good luck by touching it on a certain place. And in this statue, it's very clear where you have to touch the statue, because it's worn at that time, and it's clear for everybody where to touch it. You see, for instance, the example of a bike rack that is used really for somebody to park really their kayak instead of parking their bike. So people use ultimate particulars. You can never expect how people will use things, how people will deteriorate and break or whatever. So that's what we call, in fact, imperfection. And one of the cultures knows that very well, because they are, in their culture, they are designing, or they are really creating artifacts that are imperfect. And that's Japanese culture. They talk about Wabi-Sabi. And really, Wabi-Sabi is the culture of creating meaningful, contextual imperfections and take care of that. What we call it is not imperfection, a value of imperfection, but it's really the open-ended design. We really know that a product is never finished. So some of the things are still open, which is now in the dashed lines. Some things are really already fixed, and that are the real lines that you see there. So we are opening that to, let's say, voluntary incomplete definition of features of products. Why do we do that? Well, because of spending less energy to produce these type of products. That brings me to the change paradigm, so a paradigm for change. And the open-ended design, really, as you see it here, what we will make classically as a product and look at the ultimate particulates and really observe how people use them. And through observing them, we will have some lenses, and we would like to anticipate and change the product so that people can even change it better, or so that the life of the product becomes longer. And then we observe again, and this is an iterative process that we would like to do. The design itself, the system design, as you see, it's designing the product, the activity, and the context, is really focusing on making a virtual model and then on testing that or observing that in a physical way. The classical way that engineers or scientists do it is in a controlled way. They really want to quantify the parameters. They really want to look at reproducibility. And that's what we're all publishing in articles. We are using statistics really to define that. But there is another thing that is happening, which is open-ended and which emergent, which we cannot predict. And these unpredictable parameters really sometimes ruin our experiments on the one hand, but really our reality. And we should do that. Another thing is that, as I said, we should look at reality from different perspectives. So we do that in a transdisciplinary teams. And if you go to transdisciplinary teams, the design becomes not the design, in fact, of an artifact or an activity, but it becomes really the design of a conversation between those people that come from different transdisciplinary teams. And you will have conversations to create or design your language, because you need to understand each other. This could be on a cultural level, or this could be really on different disciplines. You need also to conversate to agree on the goals that you want to achieve together. And you see that there are iterations between all those aspects. Then you, of course, try to conversate to agree on the means that you would like to use to reach that. And then you need to conversate on really the design process itself that you would like to follow. And this iteration is continued. Once you reach results, you again create more language, and so on and so on. As we see it, the syntax for conversation is system thinking. And system thinking, as I showed, is the interaction between users and products, between users and designers, between users amongst each other, between users and the technology you're using. And all these type of syntax you need to develop within your transdisciplinary language that you're developing. How do we do conversations in design? Well, we do it through prototypes. We really do it through experience prototypes that we realize, and we make a kind of mock-ups that people can use. You see here some co-creation teams, multidisciplinary teams, and you see the students in action in our Industrial Design Center. Typically, in experience prototyping is that you need to observe what happens in the context. You can do that really in the context when you're making it or when you're using it. And typically what we learn our students is that they really should focus on what was not surprising, what they expected beforehand, and some things that they didn't expect beforehand, so that was surprising them. And this could be a desirable feature, or it could be undesirable. For instance, if you thought this or this would be the weight, but in fact it turned out not to be appropriate to take this object in that way, well, then it's undesirable. And we like to document these kind of things with this kind of matrix that is used by Schoen, in fact, that invented that. On what level do we do that? Well, we prototype real-life experiences on different level of abstraction. We could make models, simulation models, and we are good at that as scientists, and we could really make fully functional products. But in between, there are some other things, like, for instance, you can make prototypes that have low fidelity, that are not proven in detail, or have higher fidelity that you know, okay, this is closer to what we want to achieve. And the observation you can do from the outside, without the interaction, just by observing, or from within, where you try to co-experience that. And typically what you will see, for instance, that you could have low fidelity prototypes on activities like describe the interaction or describe the activity. Or you could go into the real world and look at real interactions, how humans react to the things. The object of study could look like work or a work-like prototype or a functional prototype, but could be with low or high fidelity realized. And the context you could simulate. You could really project the context, you really could make this, you could make a scenario, you could make a living lab where you're inviting the users to do this in a protected environment, or you could go out and go to the real context and observe it there. So that's really how we train the students to work. I would like to reflect that a little to how we design then for and with communities. Well, what I've shown until now was designing one product for a particular number of activities and contexts that it can be used in. But if we go for designing for communities, we believe that we don't have to design one product. We design a system of products. And we design a system of activities and interactions that communities are interacting through this system of products with each other. And they do it in a context where we have to look from many perspectives. So the sociology, for instance, but also ecology, also the technology, and so on. So really, these domains come together, and this is, of course, a very complex manner. Well, the way we do it is by cybernetics. We have a course on what's called design and cybernetics. And the principle of cybernetics are very basic. So the first is that you have a black box with inputs and outputs. You have also second-order cybernetics, where we do adaptations on different levels. We can make causal loop diagrams and archetypes. And students are trained to learn all of these. You see, of course, well, let's look at my pointer. Here you see a first-order adaptation or single-looped adaptation. What you typically have is the input will be transformed in an output, and you will have sometimes feedback loops in order to close that and to make your object working. What we typically do then is we remain in the same space of operation. We don't change our goals. Our goals remain the same. It's only the trajectory to reach it that we control and that we steer. Of course, if you go to the second order, you will make a loop where we are also changing, let's say, the goals itself. And that's what typically a wicked problem is doing. Once you have a solution, you immediately see a new insight in the problem definition. And so what you have then is a double loop adaptation, and we call that second order cybernetics, and we train students to work on that level. The way they do that is they use a kind of causal loop diagrams in order to understand the complexity. So they have to find the causes for some things and the consequences of some things. And they learn this kind of vocabulary, as you see here, and they learn to make these kind of loop diagrams on a kind of activity that they are observing in the context. And then, of course, they need to observe behavior. And how they do that is by observing the behavior in time. And therefore, they use what we call archetypes. And what's important in archetypes is that you indeed see these causal loop diagrams, but at certain moments you have delays. And these delays make that you should not immediately react, but that you should observe in time, that you should observe for a longer period of time. And this is what we train the students. And of course, they learn to recognize some of the archetypes, like that the goal is drifting, or we have fixed the problem, but it fails, or there are some limits to our success, or we are shifting the burden, whatever. These are some examples of this kind of these archetypal analysis that you can use. Well, until now, I have explained what the students are trained. And then, of course, they are trained, let's say, like in a semester of 12 to 15 weeks, they are trained in the first 4 weeks on this theory. And then they have to apply this in a case study. And I would like to illustrate a case study that we did at our campus to reduce the food waste of the students. And I will open up their PowerPoint and final presentation. And I will start by showing a movie, what they really did. I hope it will start. This is the waste center of our, let's say, our cafeteria. What you typically will see is that food leftovers can also be recycled if you separate them from the other type of, if you sort them out. And until now, everybody's putting that in the bin and together with all the other waste. And we would like to sort that. Then they also made a kind of interactive communication system of leftovers at dormitories or for students to have them. And they're using just a Facebook group to share this. So that's the problem they solved. I'm showing you the final result. The first thing they really did is really look at the feedback loops. And so they saw that, of course, if you are scooping more food on the plates, and that, of course, you have more leftovers of food, and you have more food waste. And now, in the restaurant, in the student restaurants, students can ask really to have a larger or a smaller portion. And what the student observed by doing that is that the waste was diminished by a factor of 10. So it's really 10% of the original waste that was there on food. That was the first thing that they solved. And this is just by asking to the people that are scooping the food, really, that they ask to the people, do you want to have more or less of this or the other? And another thing that they learned is that all people put their leftovers in a trash. However, food leftovers, if they would you would sort them, you could kind of reuse them. And You could give them as food, for instance, for animals, or you could do that. I agree, yeah. But that's what they did then in the sorting center. So what typically happened is that this was a first iteration that he made, and they observed with cameras. And you saw that in the beginning, even though it was mentioned that people were just putting everything in one bin. People didn't notice even the stand. And that was the first iteration. Then they labeled the bins better. And they said, okay, this is food trash, this is the recycling and the waste. And typically what you see is that people start to use it in a proper way, but that was unexpected. People coming from the right didn't notice that. And so they were just putting their food again as they did in the original way, while the people coming from the left do it in the proper way. So the next iteration was really to close on the counter the dustbin and take it out. And of course, if you did that, what you typically see in the beginning, there is some confusion. Yeah, they don't know what to do. But after a while, people get used to it. And even the people coming from the right are doing the same thing since the counter was closed. Then, of course, there was some discussion. Should we not have a lid to protect, of course, this food waste? And what you typically saw is that people were struggling with it. Even some struggling so that they destroy it, so the food waste was not useful. I want to show you some of the interventions. As you see, there are some weeks in between. You see that are the weeks that they observed, and they saw that, for instance, the labeling was observed after a certain iteration. It became better. That, for instance, the people that sorted that really 100% did it when they closed the bin on the counter. And of course, yeah, that meant that they were forced to do so. But typically, what you also could observe is that the people sorted, more than 90% of the people sorted the food in a correct way. That's the end of my story. I would like to thank you, and I would like to finish with a quote. It's my favorite quote. Change is one essential phenomenon of life. Without change, life simply stops. So do not fight change, but embrace it as a challenging opportunity. Thank you very much.